In the second item, we're asked to discuss how to determine which material from this tension test of an aluminum alloy and then a different one of the low carbon steel, which one of the two materials would demonstrate the greater toughness. We're not asked to come to a final conclusion, but rather to discuss how to determine which one is. And so really this is a definitional question, that is that toughness is defined as the total area under the stress strain curve. Note that what this really represents is the static energy, which sounds funny, but how can you have energy if you're not moving? So it's really a pseudo-static test, but the energy to cause rupture or fracture. Now it's a pseudo-static because under impact situations, which is another way to measure toughness, we're going to get a different result. The two will be correlated at some level, but under high strain rates, which is what you get under an impact hammer, you will get different kinds of material behavior. Right? So the way to determine the answer is, well, go figure out which one has the greatest area under the stress strain curve. Notice that stress times strain would have units of force over area, which would be length squared, and strain would have length of deformation over length of original. So you actually are getting an energy, force times length, of deformation divided by volume cubed, or per unit volume. So it's really the energy to rupture over length, or energy to rupture per unit volume is what we're actually getting here, is what the area represents. Now if you wanted to take a step further and say, well, which one of these two materials experiences the greater toughness, you might be tempted to say, well, the fracture strain of aluminum is less than the fracture strain of the carbon. So and notice that the carbon steel has a smaller yield strain, so the ductility capability of the steel is definitely greater. But that's not what's really being asked. That tells us a little bit about the two different materials, but it's this total energy, because of course the strength of the aluminum is greater than the strength of the steel. And so that's why we get this notion of toughness, a combination of these two different kinds of things. And so now, if you by eye were to start to say, well, okay, this is about areas. So the area that the steel has that the aluminum doesn't is shown by these two little hashed areas. Now if that's greater than the area that the what did I just say? The aluminum does not have that. That's what the steel has, right? But the aluminum has this other area above the steel. And if I try to by eye compare those two, I guess that maybe the steel has a little bit more area. All this other area is the common area between the two. I guess maybe the steel has a slightly greater area, but boy, we really have to do the calculation to have a very specific understanding of which one has greater toughness. They basically have very similar toughness, it would look like.